Sí, ok. Bueno, buenas tardes. Muchas gracias a todos por estar aquí. Voy a presentar ahora al profesor Luciano Boi, que nos acompaña esta tarde con la conferencia, con el seminario, en realidad, Arte y Ciencia de los Nudos, el trabajo visionario de Jorge Eduardo Eielson. El profesor Boi es actualmente investigador senior en la Escuela de Altos Estudios en Ciencias Sociales en París, la EHESS, particularmente en el Centro de Matemática y Filosofía de las Ciencias. Sus principales intereses de investigación incluyen varios aspectos de las matemáticas y sus fundamentos, las interacciones entre la topología y la biología, los sistemas complejos, así como la historia y la filosofía de las ciencias. Es autor de numerosos libros y artículos de investigación sobre estos temas. Ha sido profesor visitante en varias universidades e institutos de investigación, incluyendo el EHESS, el EHESS en Princeton, las universidades de Cambridge, Montreal, Heidelberg y Lisboa, entre otras. Ha recibido varias becas y premios, entre ellos la beca de la Fundación Humboldt y la beca de la Fundación Guggenheim y la Fundación Singer-Polignac de Francia. Su más reciente publicación es Pensar lo imposible, diálogo infinito entre arte y ciencia, en torno a la obra de Jorge Eduardo Eielson. Gracias por acompañarnos, Luciano, estamos muy contentos de que estés aquí con nosotros. Esta conferencia va a ser dictada en inglés, pero al final pueden hacer preguntas en español. Y además hay una serie de artículos disponibles para consulta que pueden llevárselos al final de la conferencia. Gracias a todos.
Muchas gracias por esta invitación. Perdono, io vado a hablar in inglese, però le preguntas can ser in español. I am very honored and I have a great emotion to speak here on this great artist and Peruvian poet and artist, Jorge Eielson. My task here will be very humble. I will try to underline some aspects of the work of Eielson which relate in a specific way to the scientific research, especially mathematics and physics, and also to some degrees in the life science, in biology. And also, on the other side, I will try to stress some philosophical point which relate to the work of Eielson. I will underline two things in this talk. First, there are many sources of inspiration in the work of Eielson. I think the most important, from my point of view, are three sources of inspiration. The first is the pre-Columbian work about the quipus, these first models of notes in the Inca period. The second source is the scientific and philosophical work research in our times, in physics and in mathematics. And the third source of inspiration is, I think, some philosophical idea which exerts a very strong influence on the work of Eielson. So I start with my presentation. Please, you can ask everything. Just I would not have time to enter in the specific mathematical aspect, but I will try to give some general concept which are at the basis of the reflection, of the research, of the work of Eielson in some sense, as we will see. So I think the first aspect is that we wonder every day when we observe this, in some sense, beautiful and mysterious relationship between the aesthetic character and the solid shape of object around us. There is, of course, an aesthetic aspect of any object, which is usually connected to its shape in our space, in our Euclidean space. This essentially relates to the external location of those objects in the surrounding space. However, I have some problem with my computer, I'm sorry. Yeah. Yes. Yeah, okay, yeah, that's true. Okay. So the most interesting facet of beauty rests in the topological properties of object, in the qualitative topological properties. And this object can be deformed, can be transformed and deformed as much as desired, provided that edges and lines that constitute this object are not cleaved, are not cut. Among the most topological fascinating objects interlaced pattern, braid and knot. We have knots, specifically, such as the archetypal trefoil knot, occupy a special position. We will see that Jorge was fascinated by this kind of knot. And so, from the anthropological and symbolic point of view, knot represents continuity and eternity in early religious symbolism, and they illuminate the art and the culture of the most ancient civilization. As you know, knots and interlaced pattern was developed by Egyptian, Persians, Greek, Celts, and later particularly by Precolombian people. That virtually universal art developed incessantly until now. And the most recent research in mathematics and physics related to this kind of historical vision of ancient civilization, as I will try to show. The magnificent illumination consisting of extremely complex interlaced drawing and knots in many books and in much handwork give evidence of the fascination that braids, roots, knots, and links exert on the human being, on perception, and on cognition of people. See these knots by Jorge Eielson. One of the last I think he realized is of course, one of the archetypal forms, surely among the most powerful and fruitful on every level of the existence of matter and its manifestation, is that of the knot. The knot is related with the mysteries of matter and the mystery of cosmos, as I will try to show, at one and at the same time the source, motor, and result of the organization and the production of the real world. So at the heart of the knot, there is a profound link between what is in potentiality, to use some Aristotelian word, potentiality invisible, and what is in act, visible, in this phenomenon, between the dynamic inner being and the aesthetic expression. On the right, you have an artistic vision of a mathematical knot realized by Eielson. You can calculate two things: the crossing number of the string. You have 4 crossing number of the string on the image, and you have, of course, the main kind of torsion, but I will return on these 2 aspects of the knot: crossing point and the torsion. There are 2 very important aspects of Eielson work. So, why is it important to speak about knot? It is important because knots allow for a world of relationships and interaction between the different levels of reality and between the different aspects of perception and cognition. I think it is a very important to remark this very deep analogy between the artistic intuition that gives birth to the creation of the very great variety of knots in the work of the Peruvian artist Eielson, and the essential role that these knots play not only in the abstract world of mathematics, but also in the realm of nature and of the body, of the life. In fact, Eielson seems to have grasped this fundamental point. The point is that knots and links are structures that are able continuously to build a network of interacting relations from which originates the information necessary to the shaping of the universe, the evolution of life, and the development of mind. I think it was very fascinated by this research, by this search for an explanation of this relationship between these 3 aspects. There's a self-reproducing configuration of knots and links enable nature to release new physical energies, force, and permit organisms to fulfill functions that are vital for maintaining our existence. So my first section, my first part, will be an attempt to elucidate some roots of knot theory. I will go very quickly because it's almost a mathematical part, but in a very conceptual, general way, not technical. And so, roots of knot theory in culture and in science, from the ancient Precolombian quipus to Celtic patterns, and to Leonardo da Vinci and Albert Dürer series of knots in the Renaissance time. We specially try to investigate over several centuries of culture and scientific history, and focusing our study on some very important intellectual fields and certain crucial theories and ideas in mathematics and aesthetical thinking. The major roots of crossing between cultural values and symbolic vision and artistic work and geometric creation. The second part provides a concise review of the principal aspect of knot theory and other related topological ideas, but this part will skip it. Section 3 is an attempt to throw light on some important feature of the relationship between the mathematics of knot and the macroscopic physics. Finally, last section, try to highlight a relationship between art and geometry. So what is the general significance of the work of Eielson? I will try to make to summarize some ideas, because we would need more time to go into details on this topic. So in this presentation, I will stress the great significance of Eielson's artistic work on notes. He viewed notes as an art of mind and as an art of nature at the same time. So he viewed notes as an art of human understanding, which meet in the unfined imagination of the artist, revealing a wonderful shifts of relation between many different figures of space and between many apparently distinct regions of the reality. They are virtual forms of our creative mind that are nonetheless rooted in the most intimate structure of reality and life, and are able to activate a great variety of phenomena and perception. We also attempt to show first that the geometrical and topological forms, notably types of notes, are intimately involved in the shaping of natural phenomena, and on the other hand, that nature is capable of engendering notes for its own development. Then we want to show how notes constitute a complex and very rich language, which enable us to elaborate an hermeneutics, kind of hermeneutic, philosophical vision of the relationship between object and phenomena and perception. On the other hand, we seek to show how it is possible to connect different material culture and anthropological and symbolic praxis within the frame of a new philosophical and theoretical space and vision. Let me start with this question, this basic question. What is a mathematical note? You have a very model of nice notes on the right side of the image, on my right side. Yeah, it's your right also. So to summarize what is note theory in a very brief way from the mathematical point of view. So note theory is a branch of algebraic topology where one studies what is known as the placement problem, or technically we speak of the embedding of one topological space, of one topological surface object into another topological object. The simplest form of note theory involves the embedding of the unity circle. You have a unity circle, you embed this circle into the three-dimensional space, like this space, or into the three-sphere. So generally, a knot is defined to be a closed knot, piecewise linear curves in three-dimensional Euclidean space. I will not give details on this definition. And if you have two or more knots, then we call this object a link. A link is the union between two or many knots. I give this definition because we will find later some model of knots and links in Eielson work. So a mathematical knot is somewhat different from the usual idea of a knot, which is a piece of string with three ends. We have a string and the ends are free, but this is not a mathematical knot. To realize a mathematical knot, to join the two extremities, the two ends, and then you have a knot. If you embed this circle this circumference into the three-dimensional space, and you perform some deformation. So the knot studied in knot theory are almost always considered to be closed loops. They are always closed loops. Two knots or links are considered equivalent. This is very important. I will spend 2 words on this concept of equivalence. When we can say that 2 knots are equivalent, we say that 2 knots can be considered equivalent if one can be smoothly continuously deformed into the other, or equivalently if there exists an equivalence technique. The word is homeomorphism of the three-dimensional space, which maps the image of the first knot onto the second. Cutting the knot or allowing it to pass through itself are not permitted. You cannot cut the knot. You cannot pass one of the end under the other end. In general, it is a very difficult problem to decide if two given knots are equivalent, and much of the knot theory is devoted to developing methods to aid in answering this question. Even the recent research in knot theory try to answer to this question. Knots that are equivalent to polygonal paths in three-dimensional space are called tame. All other spaces are known as wheeled knots. Knots that are equivalent to the unity circle are considered to be unknotted or trivial. So you have here an image, the simplest image of the no trivial knot is the trefoil knot which comes in a left and right-handed form. It is not difficult to see, but somewhat more difficult to prove that the trefoil is not equivalent to the unknot, the circle, the circumference, because the unknot, like the circumference, has not cross point. The trefoil knot has 3 crossing points. You see the crossing point. They are alternating crossing point. One time is under, and the second time is upper the other string. Also, the right and left-handed version of the trefoil are not equivalent if the homeomorphism mapping one into the other include a reflection. Other knots, such as the figure 8 knots, are equivalent to the mirror images. These knots are known as achiral knot, but this is a quite technical definition. So what is important is try to understand what we call complexity of knot. You have a complexity, an increasing complexity of knot. One measure of complexity that is often usually the crossing number of knots, or the number of double point, as you see in this image. You have a double point or crossing point. You have first the unknot, which is not knotted. You see the circumference. Then you have a list of knot, a table of knot. We start with the trefoil knot with 3 crossing points, and 1. The number 1 means that you need only one move to untie the knot. Okay? And then you have the knot with 4 crossing points, with 5, and the last one on the first right, you have 5 crossing points, and you need 2 moves to untie these knots. So there is only one knot with crossing number 3, ignoring a mirror reflection, the trefoil or cloverlet knot. The figure 8 knots is the only knot with a crossing number of 4, and there are 2 knots with a crossing number of 5, 3 with a crossing number of 6, and 7 knots with a crossing number of 7. From there, on the crossing number increase dramatically, exponentially. There are 12,000 knots with 14 or further crossing in a minor projection, and 1,700,000 knots with 16 or fewer crossing. So when the number of crossing is high, then you have a number, almost infinite number of knots, which can be classified in this table. What we call increasing complexity, exponential complexity of knots. So here is a much interesting thing. Jorge was interested in this complexity of knot. You see, he realized this table of knots. You have 16 knots here. They are almost with 5 or 6 crossing number, and they have almost all a special characteristic. They are hyperbolic knots. Hyperbolic knots, they have some feature which I will explain in a second. So to summarize, the complexity of knot is given by two numbers. Okay? The number of alternating crossing in a knot, and the Gordian number, that is the number of moves which untie a knot without cut it. In some cases, you need only a move to untie a knot. In other cases, you need 2, 3, and many moves to untie a knot. More of these two numbers of I more than the knot will be complex. If you have a high number of crossing number and of moves to untie the knot, then that means that the number will be very complex. So the previous image, this one on the right, this one, you see this image, is a small table of prime knots, with 7 crossing or fewer. You see this table. In mathematical knot theory, a chiral knot is a knot that is not equivalent to its mirror image. An oriented knot that is equivalent to its mirror image is an amphichiral knot, also called an achiral knot. As of May 2008, all prime knots up to 16 crossing have been tabulated. This was a very important discovery in the mathematical theory of knot. On the right, you have a table of 24 knots with a different number of crossing realized by Eielson. We discuss a lot about the tabulation of knots. Of course, what is interesting for you, Eielson, is not only the mathematical aspect. For example, the colors is very important in this classification. The form, the level of torsion. I will return back on this aspect of torsion. You see many kind of torsion in these knots, many color, of course, and many different forms. So let me spend some work on this part which concern the knot work in ancient and early modern civilization. You know that Ireland perpetuated an artistic tradition that has been developed early by the pagan Celtic civilization, famous for its ornamental use of curves, knotwork, spirals, animal design, zoomorphism, and so on. These decorative patterns can be found in the Celtic art that originate during the second half of the first millennium before Christ. Irish monks Christianized the early Celtic motif and used the term as the inspiration for much manuscript illumination. There's a chef-d'oeuvre in which there's an ornamental technique or highlighter or the illuminated Bible of Kells, Darth, a gospel possible dating between the years, and lined forms, of which the first 2 volumes are to be found in the library of Trinity College in Dublin, and the last in the British Museum in London. The rigid geometric borders and letters of the illuminated page enclose and often made up by endlessly twisting line and intertwined creatures. The interlaced ornament produced by Celtic scribes and stonemasons has fascinated people for many centuries. The design, ranging from small individual knots to elaborate panels composed of many motifs, provide the geometrically minded mathematician with a rich source of example. Many aspects of the interlaced pattern can be studied mathematically, especially the geometry of knots. Later, in the Renaissance time, Leonardo da Vinci and Albrecht Dürer executed a series of knots. Leonardo concatenation became the theme of several works. Among others, an ornamental fresco, that of the Sala delle Asse, room of the wooden boards, a name which predates Leonardo decoration, at the Castello Sforzesco in Milano, in which the artist painted a glide wire along with the interlacing of 3 bolts. At the intersecting ropes, he mixed the uninterrupted arabesque line of a rope, the loops of which appear and disappear ad infinitum in a network of leaf branches. Giorgio Vasari wrote that he, Leonardo, spent much time in making a regular design of a series of knots so that the cord may be thrust from one end to the other, the wall filling around space. There is a fine engraving of this most difficult design, and in the middle of the word Leonardo da Vinci Accademia. Then come the work of Dürer, inspired by Leonardo. Among Dürer wood engraving in the series of sex Noten, Dürer knots are most like a variation of Leonardo's well-known engraving on copper of a similar medallion. This Noten suggests a textile application. Dürer's knots could have been employed in a great variety of technique. Their likeness to Moorish arabesque was generally recognized. Some knots by Dürer are made out of wood cut and probably realized around this period. The series of 6 knots of Dürer were actually copies with a minor variation of 6 northern Italian engravings, which are thought to be based on design by Leonardo da Vinci. For example, the work Knot, a copper engraving after Leonardo, is a knot with successfully sums up Leonardo's lifelong passion for complicated drawing and allegories. The prodigiously complex ornamentation in the engraving, with the exception of the center and of the 4 coins, is composed exclusively of 4 continuous lines. Then, what is the significance of Leonardo and the Dürer knots, which from an Oriental viewpoint must be called a mandala? That is a circular design arranged in layers radiating from the center. It should be remembered that Inca craftsmen also designed the mandala in the form of calendars. could be realized as a three-dimensional labyrinth like the one at Chartres, Cathédrale de Chartres near Paris in France, if it is regarded as the plane projection of a construction looked down upon from above. The angle ornament or indicative of the fourth dimension, Leonardo concatenation, can be seen as a map of the universe. In fact, Leonardo was one of the most important sources of inspiration for the work of Eielson. He speaks a lot about Leonardo. He realized some work which he called Annodamenti e volo degli uccelli, which are directly inspired by the work of Leonardo. Some words about, so the dual sex are not isolated phenomenon in the tradition of ornamental art. Their antecedents include design found on Persian and Syrian faience and the interlaced motif of medieval manuscripts. Outside the Western sphere, the Arabs have for some time been masters of method of constructing some of the most sophisticated knots and interlacing, which they develop into ceramic paving, pavimentation, tessellation, or into the illumination of sacred text. Interlacing such as those found in Muslim art, which in passing have fascinated the American artist Frank Stella, for example, who turned to them in this protractor series undertaken in 1967, which is reminiscent in a formal manner of the interlacing in nodo done in 1985 by Jorge Eielson. So Eielson created a new universal language, that of knots, an expression extraordinary modern of pre-Columbian quipus of the ancient Inca civilization of Peru. We should remark that the Inca doesn't have a writing. Nevertheless, its methodical organization required another form of language in order to make, convey, and store the information. So the quipus had at the time many functions: statistical, counting, memory record, a kind of book for practical calculus. However, they have not only a numerical function and meaning, but also a symbolic, commercial, and cosmic meaning. The numerical function was in fact a sort of natural and social arithmetic. They invented a kind of social arithmetic. They calculate with knots, with the color of knot, with the number of knots in a string. I cannot go in detail, but it's a very, very complex technique, a very fascinating technique. The symbolic was an anthropological practice. The symbolic function was the symbolic meaning, was an anthropological practice. Was function was to conserve a tangle, a web of social relations among the different social groups in the society. And the cosmic function played the role of an imaginative and archetypal model of the structure of the cosmos. This is a kind of quipus of ancient pre-Columbian time. It's a beautiful example, I think. And this is a Eielson work, Node, of 1989. You consider, let me consider this work as one title, Nodo, and realized by Eielson in 1989. This work is a multitangle knot. Observe also the interesting interlacement. they bear a stringer likeness with Celtic knots, with some Celtic knots, and to Leonardo's as well, to certain topological knots from modern tabulation which we saw before. In spite of the apparently astonishing complexity of this knot, its crossing number can be easily calculated. The basic pattern of this knot of Eielson may be compared with three simple knots, the first of which is the bowline knot. The Alexander polynomial invariant for each of these knots is easy to compute. We find this computation in some of my article of my work. So remark in addition that the first two knots are prime knots. A prime knot, what is a prime knot? A simple definition is that a prime knot is a one, like a prime number. We learned that at the elementary school. A prime knot is one that cannot be decomposed, divided into other knots, but only into itself or the trivial knot. Every prime knot is identified with by its crossing number, upper number, and the values of its guardian are not invariant lower number. The Eielson knot may yield different equivalent-oriented diagrams. We can represent the Eielson knot on many different representations, diagrammatic representation, in a plane, in two-dimensional plane. Those for which the linking number is the same, the linking number is an invariant for oriented links. See this nodo, this other nodo by Eielson, this beautiful nodo, 1976, which is an artistic realization of a mathematical hyperbolic knot. Yeah, this is a very, very interesting realization of some mathematical knot, which we call hyperbolic knot. It is worth observing that many knots realized by Eielson are of hyperbolic type. They display a kind of geometry very rich in symmetries. Eielson was very attracted by these symmetries, by their harmony in a Platonic sense, in a Platonic vision of the world. The world needs to have some harmonies, some symmetries. So these knots display very rich geometry in symmetries, and they show that the intrinsic structure of a hyperbolic space is much more complex than that which characterizes our space, our Euclidean space, where we live. So just on the right side, you have an image of a mathematical hyperbolic knots, which is the boundary. Why we call a hyperbolic knot this a kind of knot? Because it is the boundary of a surface which with negative curvature minus than 1. And in the 98 years, it was proved, demonstrated by a very important mathematician, which is William Thurston, that every knot, with the exception of a certain specific type of knot, which are called the torus knot and satellite knot, is hyperbolic. Most of the knots in the mathematical world are of a hyperbolic type. This is a very interesting fact. You see here two types of hyperbolic object. I don't know if you recognize this hyperbolic object. What do you have on the right side? This is a very important work by Leonardo da Vinci. Is a drapeau, a drap, a cloth, realized by Leonardo. And on the on the link side, you have a closer and handwork realization of an hyperbolic surface. Let me go a little bit in detail here. So the previous image on the right, you have the drappo of Leonardo da Vinci. Drappo per una figura seduta. How you can translate that? Drappo for a man, or a person which is seated. Figura seduta. So this drappo by Leonardo is a beautiful example of a textile drape with a negative curvature and infinite crease. Pieghe, pli. One of the most important features of a hyperbolic space is that each of the sections is an hyperbolic place. In some sense, it's like the criterion of autosimilarity in fractals. It's the same thing. From the mathematical point of view, it's the same. If you have an hyperbolic surface, like the previous one, like that, then every section, if you take every small section of this surface, then you obtain some hyperbolic plane, which corresponds to a fractal object. A fractal object is the one that conserves its autosimilarity from the big to the small scale. Okay? When you pass from the big to the small scale, you find always autosimilarity. You find the same form, but at a smaller scale. Okay? And on the right, we have this beautiful realization by Leonardo, which is an infinite number of pieghe, of pli. You see, is a very hyperbolic. If I try to take a section of this drappo, I realize some hyperbolic, very interesting space. So, on the links you have an handwork embroidery, crochet, ricamo in Italiano, in Italian, as an example of a hyperbolic space to which apply the same properties of the drappo. You have two very different objects, but the topology of the two objects are very similar, or very, very similar. I like both. This is handwork made by artistic artisan, by many people, no? For example, the Mediterranean countries you can find in many small villages, in many cities, this kind of work. And of course, that by Leonardo is a very important work. So from Leonardo to Eielson, a long path of creativity and a quest for the fabric of the universe. It is to Leonardo that Eielson refers in his installation entitled Code on the Flight of Birds and on Nothing, Codice sul volo degli uccelli e sugli annodamenti, Code on the Flight of Birds and on Nothing. It's a beautiful work by Eielson. And you realize the same idea in a quipus of 1994, quipus 20B, Codice sugli annodamenti e sul volo degli uccelli. This is one, you see. There are a series of these quipus. Quipus 20, Codice sugli annodamenti. So Leonardo is one of the most important promoters of the dialogue between art, science, and nature. Certainly one of the most important, based on the fundamental role that he assigned to the dynamical force and to the forms which change in space and evolve in time. If you read the manuscript by Leonardo, you really find this philosophical idea. It is a strong philosophical idea, which is the same idea that motivated Eielson, from my point of view, to do this kind of works. Leonardo was convinced that the concrete existence of individuals is intertwined in a multiform way with the transformation of natural and social space. For Leonardo, all is immanence, and the cause, the reason of phenomenon has to be searched in the properties inherent to nature itself. Leonardo was certainly influenced by a kind of natural philosophy, the same developed by Lucrezio and before by Aristotle too, and later on this kind of philosophy was developed by the German philosopher, the natural philosophy in Germany, the Naturphilosophen in Germany, what is a very important part of the philosophical tradition of our continental philosophical tradition. So let me spend some more word about the knots seen as the actual form of the potentiality of the canvas. The knot is one of the roots of Eielson art, or rather, it is a fundamental form spanned by primitive act. This act applied to the primordial knot or obtain myself able to create knotted object. In fact, this act corresponds to topological paths, which may be deformed one into the other. They would therefore be called technically isotopic, equivalent, isotopic. They can be deformed one into the other. The knot, primordial form created from a canvas, which a nucleus that is a twisted string in Eielson work. It twists the string. This is a very important operation, a very important transformation, to twist a string. This string is at the same time flexible and stretchable in all directions. I saw many times Jorge and Michele try to stretch to make a torsion with the textile, and this twisting condenses the flatness of the textile surface into a space that has meanwhile acquired some volume and a new dimension, as well as a much richer dynamic and qualitative structure. This is equivalent to saying that the surface from the anonymous space where a string is immersed becomes a special entity of its own through its unfolding in time. We could thus say that the knot identified here with this structure is the forming act of the potentiality of the surface or of the canvas. In Eielson's case, this form deploys and transforms itself from one work of art to another, adapting itself to the space it appropriates, to the material structure, as well as to the configuration. So there is a reflection in Eielson's work on space, I think, that captures the topological potentiality in the torsion of the knot. The torsion. The torsion is a very fundamental gesture. It's a fundamental act. This torsion has the property of binding itself, and it becomes one with that to which it is bound. The knot suggests the complexity and the perplexity of an interaction with oneself. It passes back of itself, above and beneath. The force of the knot are made manifest in the interlacing form. The spatial compression involved in the knot has the effect of an implosion, like this one, you know. If you look on the right side, this knot is the result of this torsion, of this stretching of the textile here. come a little back. Yeah. You see that the knot in Eielson work is often placed along the edges of Eielson paintings, like here, you see, because you have to stretch to make a torsion here, very, very big tension of the textile. I'm sorry. So in addition to the beauty, many quipus by Jorge Eielson display interesting features related to the way in which space can be shaped and its dimension pushed far beyond the material limits of the canvas. New physical energies are liberated by the many different but to closely related configuration Eielson gives to knots and braids. One could say that the role Eielson assigned to knots is to be the aleph of space, to use an expression by Borges. Yeah, Eielson is searching for the aleph of space, and the knot is a way, is a path to find out this aleph of space. The aleph of space, the universal and life. Like Borges and Paul Valéry, Eielson is inclined to believe that the world is a wonderful and mysterious combination of ordered contingents and fundamental symmetry, of conflict and harmony, of singularity and universality, poles which, however, are necessary together. They are not incompatible, they are not opposed, they are very composed together. They make a composition. The knot, as to say, encapsulate all these features in a compacted, meaningful, and beautiful form. But the knot in Eielson has also a cosmological significance, a very important cosmological significance, very deep meaning from the cosmological point of view. So, as I said, in topology, the knot is a dynamical object. It's a very, very dynamic object. It's not static. It's never static. It's never static. It's a dynamic object. I will give some example on Monday of this dynamic of knots in physics, in biology, and in other fields. A dynamic object allowing for the transformation of space according to a certain type of embedding. Through analogy with physics, it can also be said that the knot is a center of gravitational energy that would attract all neighboring body. This is the knot for Eielson. On the other hand, it allows for other forms of energy than those that actually exist physically. When a knot appears within a surface, an object or a living organism, it is a new dimension in the structure and the behavior of this surface, object or living organism that emerges and grows. In the piece entitled Disco Terrestre of 1991, for example, of Eielson, in which the knot is situated on the lower edge of the canvas, like here you see, in a circular form. There is a strong sense of this sort of elusive gravitation of the knot, which captures a propulsion of energy within its very center, a mass of matter in relation to the impulsive force. Eielson sculpted a black velvet knot, achieved in 1996, is a specific reference to the black hole in certain cosmological model proposed in the 1917 by Stephen Hawking and Roger Penrose. Penrose is the last Nobel Prize in 20,000 in 2020, I'm sorry, for its discovery in the fields of black hole. Look at these. This is the disco terrestre with torsion. This string is a very torsion. The torsion is what we call a double curvature. You curve the string, but you need to curve 2 times the string to obtain a torsion, you know. Every string can be receive this torsion. It has to be flexible. It has to be a textile, flexible and stretchable, you know. And it is a disco terrestre with a knot on the edge of the surface. And of course, the knot encapsulates all the energy which is liberated by this tension, by this organization of the space of the surface. And the knot score of a black hole from where no more light will emitted is a representation of this cosmological model by Eielson. So you see the center, you see this circle. Black holes can emit, black hole can emit black body radiation with a wavelength on the order of size of the black hole, but this is physics, and the classical equation for space-time physics say that any photon, any light particles, photon, emitted inside black hole will bend in a circle, will curve in a circle inside the event horizon. I remember the realization of this note by Eielson. We discussed a lot about this cosmological model, and you were very engaged in this work, try to represent this kind of black hole, is a kind of cosmological model of black hole. So let me say, maybe I can take 10 minutes, or we have time? Or not too tall? You can resist to not still 10 minutes? I can resist. But you? Yes? Sorry? No worry. So, 2 words about knots complex energy. Yeah, because there is a complex of knot, and knot liberate energy and encapsulate energy. Let me make 3 brief remarks about that. So, first, one could say that the mathematical type of knot measures the order of complexity of the reality. For example, the transition from the trivial knot, that is the U-knot, the circumference, to the trefoil knots, the simplest knot with 3 crossing number we saw before, and from that one to the wheeled OKI knot corresponded to an increase of complexity in the organization of the organic and inorganic matter. We can demonstrate that. We can demonstrate physically, concretely. The second remark is that the creation of many different knots model for the same kind of matter satisfy to a fundamental process of nature. What is this fundamental process? This process consists in reduce a state of disorder in favor of a situation more and more order. That's knots play a very fundamental role in this transition from disorder to order, which is the most important point of chaos theory, as you know, and which possess more and more richer structure and invariant. Moreover, there's a like knot structure revealed to be essential for assuring a certain stability of natural phenomena and of living being. Knots are related with stability, with the stability of matter, let me say. If you have not the structure, the matter will be more and more dissipative. There will be more dissipation of energy, of light, of particles, and other form, all kind of force. In fact, one of the most important discoveries was made by this Japanese mathematician some years ago. He proved that the minimum energy of a knot really does increase as the knot becomes more complicated. Only a finite number of topological different knots exist with energy less than or equal to any chosen value. This means that topological type of knot can be ordered in terms of their energy. This is a physical feature of knots. Knots are not only the abstract object, mathematical object, but they are physical objects. They influence the physics of the world, the physical properties of the world. There is a natural numerical scale of complexity for knots, ranging from simple knots at a low energy. When you have a low energy in some portion of matter, then you have simple knots. For example, in a fluid, you take a fluid form knots. If this fluid has a low level of energy, the knot which we will observe, they will be simple. And if the fluid will be with a high level of energy, then the knot will be very complicated, very complex. So knots has to be with lower and higher level of energy in a portion of matter, especially in fluid matter. In the fluid, remember that Leonardo was the first to theorize the importance of knot structure in fluid. He make a lot of drawing, in which he shows the importance of interlacing structure in fluid. Yeah, that's it. I have forgotten to translate this Italian slide in English. I skipped this Italian. So, okay, this is a mathematical one. This is 2. Let me go. Maybe I will return back on this aspect on Monday. So here we have the 3 different kind. You have a physical knot in the middle. You have a mathematical square knot, this is 1. And you have the trefoil knot here. This is not a mathematical knot because the ends are not joined. And on the right side, you have a mathematical trefoil knot. This is a physical knot. The ends are free. And so you have the difference between a physical knot and a mathematical knot. Here you have a circle, which is not the circumference. This, it seems to be a knot. We perceive this like a knot, but it is not knotted, And you can demonstrate that with a simple deformation. You can untie these and demonstrate that it is not knotted. And on the right side, you have a trefoil tube-like knots. Yeah, what is represented in this image is that you need some moves to untie this knot, this trefoil of knot, go this step to the following one, to this step, following the, and you obtain this circumference. You can do that in 2 processes. You can tie the knot and you can untie the knot. You can obtain a knot, you can conversely obtain an unknotted form. So this is a grammatical representation correspond to the same note. They are visually different. You see as are they very different from the visual point of view, but in an intrinsic way, say topological, they are a topological equivalent. What means that? Means that they can be deformed one into the other by a finite sequence of moves. They are called Redemeister move, from the name of the German mathematician we introduced in these moves. They are a kind of, we call that planar, on the plane, isotopy. They are moves. So these two knots, called the Perks knots, or anti-killer. Anti-killer means that each knot is the mirror image of the other. Otherwise, the two knots are invariant by reflection or mirror symmetry. If you apply a mirror symmetry, you obtain the same knot. The two knots apply to the mirror symmetry. Okay? So let me maybe finish with this slide. I think Eielson was thinking that knot is a kind of force, as a field of force, and also an attractor of energies. In fact, in his work, Eielson shows that an energetic force of the knot. The knot is the locus of the articulation of the string, spring from the material and dynamical space of the canvas. Some force acts on the string in a way that it acquires the shape of a knot. The knot is a living form, that encapsulates the energy liberated by this force. An analogous idea has been developed by the artist Robert Morris, for example. We know the significance Morris attached to the understanding of the force of gravity as it is exerted on an object in a given space. Now, with Eielson, the knot carries with it a strength that contracts and shapes space, in addition to being a nucleus from which the twisted string, the folds of the canvas and the textile surface itself spread out. The space of the work of the canvas, having undergone changes because of various energetic propulsion of the primordial knot, is also treated with a much broader space in which the artist's imagination can exert all its force. Through the form of the archetypal knot, a concrete writing of the world, by means of which a more poetic vision of the universe can open up. Eielson makes the transition from the singular to the universal, from the infinitely small to the infinitely large. This is you see, this is a quipus 66, 1991. This quipus is shaped by three components, deeply interconnected and they cannot separate. I'm sorry, this is in Italian. So, yeah, so this is a very beautiful quipus by Jorge. You have on the leaks some torsade, some string which has a torsion. In fact, is a braid. Is a braid. What is the name in Spanish of braid? Trecha. See, yeah. And you see, it's a trecha, no? It's like the DNA of our molecule. Is a trecha. The DNA is exactly this one. And on the other side, on the right, you have this tension, this very high tension of energy. Sorry, I just so maybe what we can do. I stop here, or I can continue. How do you want? Can I stop here and then continue on Monday? The second part will be Monday. So the second part of Monday will be about, I can show the slides. So I will speak about notes as essential as essential for, for the maintaining and regenerative of life. I will speak very briefly about the notes in DNA molecule in the life and the role which notes play for the maintaining of life. And I will say something about the poetic work of Eielson, and I will finish with some quotation from Eielson and some quotation also from a poet which was Eliot, which exerted a very deep and constant fascination on the Peruvian artist and poet Eielson, especially this quotation, which is very important in order to understand the poetic and the philosophical meaning of Eielson work. Okay, so I stop for the moment. I stop here, and I will continue on Monday this other aspect of the work of Eielson. And what I would like to stress is that in some sense Eielson anticipated some recent development in science, especially mathematics and physics. And on the other hand, he was inspired very deeply by this development. So the work of Eielson is a crossing of the pastime, the civilization, the history, and the anthropology of civilization, but is very strongly related with our recent research for find out an explanation of some mysteries of space and of time. Thank you for your attention.
Pasemos a las preguntas. Quiero recordarles que tenemos material para ustedes. Así que por favor no se vayan. Para tomarlos y por supuesto seguir conversando de manera más profunda, con más detalle, el lunes en la segunda sesión del profesor Boi. Y aprovechemos, por supuesto, para trazar cualquier daño, duda, arrogante que tengamos luego de haber escuchado estas múltiples interpretaciones alrededor de esta interesante forma de reflexionar. ¿Alguien tiene quizás una pregunta?
Bueno, realmente fascinante y muchas gracias. El tiempo que requería la construcción o fabricación de los nudos en las manos de Jorge Eielson y Michele Mulas, se puede decir que ese tiempo está implícito cuando miramos los nudos de Eielson. Y una pregunta paralela, ¿en qué medida, porque tú hablaste del espacio, un nudo los nudos estabilizan el espacio. ¿Dónde está el tiempo en esa situación?
Yeah, I think the time is not an extra dimension which adds to space dimension. I think time is a very internal dimension of the work of Eielson and Michele also. So they need after some time. They need that their work evolve in time. They need not, for example, I think one of the most interesting philosophical aspect of the work of Eielson was his anti-reductionist and the mechanicist vision of the work, of the artistic work. We have had many discussion about that if you apply some mechanical operation, which are very, very quick, you can do very quickly, then you have some kind of time, you know. But I think for Eielson and Michele also, what was very important was to develop very in time. The time was a very important dimension of the work. You see, the time was inherent to their work, was intrinsic, profoundly related to their work. Time was not an external factor, an external aspect. It was very, they take time. They work in time. But they work in a continuous way. They never discretize the work. You know, time can be a way of discretizing our activity, our work. Discretize, that means you cut. You cut your activity in many different moments and you lose the continuity of the work. I think Eielson was, he has another vision of time. Time was a continuous reflection about the work which has to be made. And many times it takes a break, a moment of reflection, of meditation, and put the work on the side and then reflect on the implication of this work, on the way to reach some results. And so time was very inherently related to the work, was very important. And I am sure that a knot as an evolution in time is not eternal knot. I mean, it's not static, not eternal. A knot has need to be constructed in time, need to be realized in time. Yes, is one time the knot. It takes time. For example, if you take a fluid like a vortex, you know, the vortex, you have the vortex everywhere in the fluid, in the atmosphere, in the fluid, in the so they form knots, and they form knots in a certain dimension of time, in a certain in some time, yeah. And what do you think about this aspect? You would agree with this vision of time, or?
Yeah. Thank you. Yeah.
Sí, pensando en la obra plástica en general de Eielson, por lo menos yo pienso que está más o menos en cruce entre minimalismo, primitivismo y expresionismo, quizás, ¿no? Ahora, viendo las obras con los nudos, como usted ha demostrado, que están conectados con matemática, ciencia y otros temas más profundos. Esto no es evidente en la obra al ver la obra, ¿no? Entonces esto queda más o menos oculto. Y yo, no sé, pienso que el observador común no va a ver estas conexiones y va a consumir la obra de manera más estética, ¿no? O más formal, ¿no? Que yo creo que también bastan por sí mismas. Ahora, pensando en todas estas relaciones que nos ha mostrado, estaba pensando, y nunca se me había ocurrido antes, si podemos considerar también a Eielson como un artista conceptual con ciertos excesos esteticistas, no sé, pensando en esto.
If I understand well the question, yeah, I think is the work of Eielson is not only I think the fundamental aspect is not the aesthetical aspect of his work. I think is yeah, there is a part which is a conceptual work. In this sense, it can be assimilated to a conceptual vision of art. I mean, conceptual in the sense that behind this work there is always a kind of a reflection about the movement, the operation to do in space on the surface of the canvas in the time we need to do that. But at the same time, so for example, a conceptual aspect was that I find that in the work of Eielson is an important part of hypothetical, speculative, conjectural vision. You know, he conjecturate, he make hypothesis, and then he put all these hypotheses in the work, in the concrete aspect of the work. I mean, the notes for Eielson was a kind of a concretization of the universe of reflection, of meditation, of concept he develops. For example, he has many books, I remember, on quantum mechanics. He was fascinated by the vacuum of quantum mechanics. And he believes that the vacuum of quantum mechanics is not actually a void, is not a vacuum, because there are a lot of particles which are growing, emerging in this vacuum. No? So I think that there is a very important relationship between the aesthetical, conceptual, and concrete work by Eielson. The three aspects are very intimately related. Or what do you think? For example, he speak sometime about Duchamp, Marcel Duchamp, which was kind of representant the conceptual art. But I find that there is a very profound difference between the work of Eielson and the work of Duchamp. Duchamp was a really conceptual work in the sense that it was a much more intellectualistic work. It was much more, not abstract, but it was much more about the language, about the linguistic aspect, about the formulation of concept. Eielson not. It was not the linguistic aspect of the. Of course, in the poetry and there is also the linguistic aspect, which is very fundamental. But in the artistic work, I think the main point was not how to say that, this intellectualistic aspect. I think he was really interested by discovering the relationship between some K concept, like the knots, and in which sense this K concept can be or can acquire a concrete existence in nature, in the real world. That was, I think, the strong point, the main important point of this work.
I have three things I'd like to share. One relates with the first idea of time, and the other one with the linguistics. So about time, he has some performances in which he acts. No, he did as an act, but he makes the knots as a performance. And in that action, I think the notion of time, the notion of audience, and the notion of a story or something being told through that action is, how do you say this in English? Clave, no? It's key, no? And so I think there is a meaning with the time, no? And I think it varies with the specific space where it's been done, no? Like el cuerpo juliano, no? Or el gran quipu de las naciones, no? Of Munich. So that on one side. And then the topic of linguistics is very curious in Eielson's work because, yes, you have the poetry, but you also have alfabeto, which is a visual, no? But it puts that question of linguistics in a visual way. It questions it, no? So there's like a limbo, an interesting limbo here, no? And my third question, or my third commentary is, so we almost, or we're going to see more the third point of this on Monday, the cosmological aspect of the knot, no? And my question has to do with how this cosmological aspect relates with Eielson's view of the sacred, no? Because Eielson has a variety of work on this idea of the sacred, of the divine, no, I'm not sure if the religious is the word, not the correct word, but it's interesting. It's interesting how the knot can become or be, no, this cosmological vision, cosmovision, no? And how this can relate to the divine, no? This is also interesting if you connect it to Da Vinci, you know, or Vasari, or etc. No? So that's those three things I wanted to share.
Yeah, interesting question. It seems that you know the work of Eielson more better than I know. That I can learn from you, maybe. So, first aspect. The work of Eielson, this is the meaning of its performance, is an active work. It's not passive work, it's an active. I think in his action, in his performance, he displayed the vision of time. He needs times. He needs time. Time can be also a moment of silence. You know, silence is time for Eielson. Is not only to speak, and you know, the time is not only linguistic. You know, is not only to speak, to be active in this sense. Time has many manifestations, has many ways of be active. For example, I remember one time I was invited at the museum, at the center of Boubou, Centre Pompidou in Paris, and they invited him to read some poems. and refused to do that because he wanted not to have a public. And then at the last, he accepted that, but instead of read the poem, he rested in silence. And the performance was the silence. You know, it was time. Time is like so there is some observation and reflection of Beckett, Samuel Beckett, about the importance of silence, and also of Borges. I think both has had an influence on the Eielson vision of time. Time can have many manifestations. What I want to say that I think work is not a modern thinker, because one of the characteristics of our modernity is that time has to be is identified with velocity. You know, time is a velocity today. If you are not, if you know, go quickly with velocity, you are lost. I mean, you have not possibility to reach something. The vision of Eielson, like the vision of many philosophers and people active in science, it was exactly the contrary. Time need to be discovered. Time is life. If you have no time, you cannot live. You cannot be active. You cannot be. So this was one of the. I don't know if I answered to your question, but this is a very important problem. I think that we have many. There is not a unique dimension of time. You have many dimensions of time. The time of my perception is absolutely not the same than the time of the physics. The time of my cognition or the time of my life is not the same as the time of my emotion, of the time of mechanics or the scientific activity. I think they take time. Every moment was full of meaning for Eielson. Even the moment in silence or spent to converse in conversation in a very rich, peaceful dialogue was a very precious time. You know, time is a kind of precious way of life, as a style of life, a form of life, in the sense. In one time he quoted Wittgenstein. The sense of Wittgenstein that time is a way of life, is a form, a style of life. If you have no time, you cannot realize a form, a style of life. I agree completely with this kind of observation. And concerning the linguistic aspect, I said in my remarks, one of the remarks was that for Jorge the Notes was a new language, but not in the linguistic sense of the word. Because I think that the linguistic sense of the word is too reductive. Language is another thing. Language has a meaning, is not only the grammar, the syntax, is especially the semantic. You have a language of forms, by which you have to understand how forms originate, grow, and evolve in space and time. How they transform space and how they evolve in time. this is a language, is a complex language. And to realize this language, you need main tools. You need not only this to speech or the linguistic aspect. You need, for example, you need the gestures. When you make a torsion, you don't speak. You don't need to use words or sentence. You need to have a series of gestures, and this gesture productive was of a form of thought, of thinking. Gesture is thinking for Eielson. To make torsion, to make tension in the canvas, in the surface of the painting is to produce something new in the language of arts and of. I would make a difference between the linguistic aspect and the meaning of language we assign to some kind of languages, in some sense. Let me. This was not your question. The question was more precise. Yeah. Mm-hmm. Mm. Yeah. I have maybe a poem of Jorge Eielson concerning language. I'm sorry, no, it's not here. No, we will return on Monday. We will speak about this aspect again. Yeah, but it's a very, very difficult question because this center of Sant'Agostino. If you ask me to define time, I cannot define time. But I know what to do, what I can do with time, in time and with time. But there is no definition for time. Of course, physicists can give a definition. For example, Einstein gives a definition of time for his special and general relativity theory. But at the same time, Bergson, the French philosopher, gave another definition of time. He said that the time of consciousness, of emotion, of perception, can be not the same as the time of our clocks or laws of physics. There is a completely other natural time. It's another way of time. I think the artistic work has a specific way of constructed time and of yeah.
Luciano, I have a question. Clara was saying that notes are decisions too. Right?
Yeah.
And I was thinking, yeah, it's like No, you mentioned Borges too, and I was thinking of the garden of forking paths. No? You take one path or make some torsion, and then how do you decide which will be the next step? No, my question will be like, what is the role of chance in this process of making the knots?
In practical work for obtaining a knot, chance play a very important role, because well, when you define a knot mathematically, you follow a series of steps. You need to follow a series of steps, which are coherent among all steps are coherent. And if you want to untie a knot, you have a series of moves, of steps. And these steps possess an order. Yes. You cannot escape to this order. You follow this step by in a certain order, you know. When you construct physically, artistically, and not like Eielson, even if behind there is a reflection on the conceptual vision of I mean, it was not a practical work, that of Eielson. It was inspired by a reflection of the knot, the form, the operation to do during the work, but the chance, for example, the role of errors was right. Important, because they make a lot of errors. You know, the torsion was not the good torsion. Then they need to start again this operation. You know, well, the errors plays an important role also in mathematics. It's a kind of creative role. It's very important. To make errors is very essential. But when you make physically something concretely, I think I don't know if it's not only chance, but you have not a path already precise and ordered. Designed. You have to find out the following step. You have maybe a general representation of the step you need to do, but not of the order. For example, if you take this disco terrestre with torsion, you can. There is not every torsion is a little bit different in respect with the order. There is not a strong similarity. There is not, you adjust some things. You have to make, and the same for the disco terrestre. Maybe this tension is not the good tension. Then you have to perform a better tension to obtain a better knot. So I think the contingence aspect, you have not a program. The artistic work cannot be programmed. You cannot have a program. Even life has not a program. When we born, we are not the result of a program. There is a kind of contingence of chance, you know. But in the artistic work, this contingent factor is very important. So each step is, in some sense, is a new discovery. You have to make step by step, and then. But maybe there is an orientation. It's not only on a chance, because if you have not a vision of the work to realize, you cannot reach the result, you know. You have in mind what kind of knot I can do, which kind of form I want give to this note, and then try to perform my concrete operation in substance toward this goal we have to reach.
Can I follow with one final question? I was thinking about the discourse that you're displaying here because they are after the notes. So what is your interpretation of making torsions in the notes and then displaying the notes within the circular form? I don't know. From my point of view, I think it's a way of condensing or trapping energy in the note and then releasing them in these discos, for example, right? So how do you see that in the gestual language we've been discussing, or within physics and trapping and then releasing energy?
Well, yeah, it's a kind of a gestual language. I think it's very difficult to realize. I'm very impressed by this work because it's very difficult to obtain some kind of this kind of work, you know. I mean, distortion is quite simple to define. We know what is a torsion in mechanics, what is a torsion in geometry, what is a torsion in many things, but realize a torsion with a concrete object is very difficult. But I think that the torsion is a fundamental step in the path needed to realize a knot. If you have a knot torsion, you cannot have a path. There is a difference between a mathematical knot and a physical knot of Eielson, because in a mathematical knot, the deformation is smooth. You don't need to make a torsion. You need a deformation, but not a torsion, you know. It's like if I take the lace of my shoes, I can make a torsion, but I can make a knot without torsion. In the case of Eielson, the torsion is very important. It has many functions. I think it has first as a mathematical function, because the torsion, if you have a textile object, you cannot, you know, it's like you have to make a torsion, otherwise you cannot realize a knot. And it is also important because this torsion is a condensed form of the energy. Is a condensation of energy, the torsion. No? Well, I think it's really one of the most important aspects of the work of Eielson. Torsion is a gesture of life. It's a gesture of art to realize this work, but it is also a gesture of life. In nature, you find a lot of torsion. For example, you have many kind of vegetable with make torsion. We have a lot of flower with make torsion. We have a lot of animals with make torsion. Take the example, very interesting example of the, which is the name in Spanish, limaçon, la lumaca, you know, these animals with make a torsion. Limaçon, lumaca, what is the name? Sorry? Si. They make a torsion to realize the form. When they grow, the torsion is really fundamental for the growth of the form. So torsion is very important in life, in nature, And I think that Eielson was very inspired by this role of torsion in this many manifestation of the real world. But from the artistic point of view, is an essential step in order to obtain. If you look at these what should it? You can maybe this light. You can move off this light. This is one. You cannot make off the light.
Levi, ¿puedes apagar la luz, por favor?
Muchas gracias.
Gracias.
You see, yeah, this is a very, I think it's beautiful. It is a kind of intrinsic harmony, but it's not a static harmony. It's the results of this operation, of this gesture of torsion, you know. But these, all these operation like these notes, this torsion of the note, of the string, I think the name disco terrestre with note is very important. In this case, the title is meaningful because you have a kind of harmonic universe. You know, you have a kind of harmonic world. What is your interpretation of torsion, the work of Eielson? He realizes form, he creates form. But form they can transform, they can deform, they can adapt, they can evolve. Forms, you know, form have a language, have many language form, but I think he was fascinated by the world of forms. And these forms are meaningful because as scientific, philosophical, aesthetical, concrete meaning, as all these meanings which are related. When you create a relation between these different meanings, that means that you have really created something very new. Thank you. See you Monday.